Hello students, in this video we will learn fundamental theorem of arithmetic. Students, recall that any positive integer can be represented as a product of its prime factors. For example, 15 can be factorized as 5 into 3, 1771 can be factorized as 7 into 11 into 23, 360 can be factorized as 2 into 2 into 2 into 3 into 3 into 5. Before we proceed with fundamental theorem of arithmetic, let us see how to factorize 360 using factor tree method. In factor tree method, we start with dividing the given number with the first prime number, that is 2, and keep on dividing till it is divisible. If given number is not divisible by first prime number, then we try with next prime number and so on. We keep on making factors until each branch of tree ends in with a prime number. Students, are you able to link that it is nothing else but prime factorization only, which you learned in earlier classes? Divide 360 by first prime, that is 2, we get 180. Again divide 180 by 2, we get 90. Again divide 90 by 2, we get 45. Again try dividing 45 by 2, but you know it is not divisible by 2. So let us try with next prime, that is 3. 45 gets divided and we get 15. Again divide 15 by 3, we get 5. Here 5 is prime number, so we cannot factorize it further. Now both the tree branches have prime numbers, so the factorization process ends here. 360 can be factorized as 2 into 2 into 2 into 3 into 3 into 5. If any factor of a composite number gets repeated, it can also be expressed as multiplication of primes raised to their power. Students, you have rightly observed that every composite number can be written as the product of power of primes, and this is called fundamental theorem of arithmetic. Let us now formally state this theorem. Every composite number can be expressed as a product of primes, and this factorization is unique irrespective of the order in which the prime factors occur. This statement can be written mathematically as C equal to P1 into P2 into P3 up to Pn, where C is a composite number and P1, P2, P3 up to Pn are all prime numbers, where P1 is less than equal to P2 is less than equal to P3, which is less than equal to Pn. Students, you may be wondering, what is this word unique? The statement that factors are unique means that number of prime factors cannot be reduced or increased. Students, you will recall that prime factors, which are also unique in the sense they can neither be reduced or increased. However, the sequence of factors can be changed in any way, and it will not affect the factorization. For example, the unique or prime factors of 210 are 2, 3, 5 and 7, which can be expressed as 2 multiplied by 3 multiplied by 5 multiplied by 7 equal to 210, or 7 multiplied by 3 multiplied by 5 multiplied by 2 equal to 210, or 2 multiplied by 5 multiplied by 7 multiplied by 3 equal to 210, and so on. Observe that in whichever order we write the factors, this set of prime factors always remains same, that is unique. This method is also called as prime factorization method. The fundamental theorem of arithmetic is not applicable to the real number 1. Let us see why. As we have seen that the fundamental theorem of arithmetic is applicable to composite numbers only. Since 1 is not a composite number, the theorem does not apply to 1. Students, you will recall 1 is not prime number also. So in this video, we have learnt about fundamental theorem of arithmetic. The fundamental theorem of arithmetic states that every composite number can be expressed as a product of primes, and this factorization is unique irrespective of the order in which the prime factors occur. The fundamental theorem of arithmetic is not applicable to the real number 1. In next video, we will learn about the important applications of the fundamental theorem of arithmetic in mathematics to find out LCM, SCF, etc.